Alright, so problems 2 and 3 on your optimization homework. Well, I haven't gotten that back to you yet. I'm going to go ahead and check them while... Alright, so I'm going to do an example of numbers 2 and 3. So, similar to 2 and 3. Okay. So, the example for number 2 is I need a... Let's wait for it. Okay, there we go. We have a closed rectangular box. Okay, with a square base, and just listing details here, square base. Okay, we're using let's say we're using 200 feet squared of material. Okay, and that's about okay. Yeah. It's closed, so that's very important as well that we know that it's closed, because then it has a top and a bottom. Okay.
So this one will have no partitions.
There are no partitions here. It's a closed rectangular box. So what we need is a model. Okay. A model right here. So our model is going to be a closed rectangular box with a square base. Alright, so we have to create a nice 3D image. You know, I'm sorry if you're not good at drawing three-dimensional. I am not either. I like to do it on line paper. That way I don't mess up. Okay, and the ones that are behind, just make them dotted. Alright. What is this? This is actually a prism. In fact, any box that you get from Home Depot or wherever in the mail, UPS, any box that's shaped as a rectangular, something or other, okay, that has if it has a square, what's the word? A regular base, equal sides, all right, and equal angles. It's a prism. So you can have rectangular prisms with a rectangular base. This is a square. Actually, this is a square prism, okay, because it has a square base. You can have a circular prism, and that's just a cylinder. That's a circular prism with a circular base. You can have a triangular prism with a triangular base. So prisms are just objects that have equal bases. I know that's a lovely drawing. I'm just saying, it's awesome. So, all right. So here we have our base, and I'm gonna name the bottom sides. Why am I naming the bottom sides? Because I'm dealing with surface area. Okay. And let's talk about, before I get into the secondary equation, let's talk about the primary equation and the thing I forgot to list.
Wait, Coach, are you labeling like the full side or like just the line?
Just this side right here.
Okay.
This side is S, this side is S. Okay, so let's talk about what we're optimizing. We're maximizing volume. Okay. So our primary equation automatically becomes a volume equation. That's it. I know it. I automatically know it. Now the volume of any prism is big base times height. And this stands for the area of the base. Okay, so what's the area of the base? This is a square, so what's the area of the base? S squared. S squared times height. There we go. We've got our primary equation.
Hey, Chris, but wouldn't the area be the amount of material that you have? Or are you just talking about?
No, this is total material.
Oh,
This is total. So this square is just a little bitty piece of that total.
okay.
Okay? So, all right. So notice our issue. Here's our issue. How many variables? 1, 2, 3. So can we just take a derivative and set it equal to 0? No, because we have too many variables. All right, so that's where the secondary equation comes in. The information you've been given about is feet squared of material. That pertains to what? What is the variable's value squared? Area. It tells us about area. Okay? So our secondary equation is going to be about the surface area. So we have to build this equation with our knowledge of just basic geometry. Okay? So let's build it down here with, let's label the parts of the surface area. So let's look at this one. What's this part right here? Okay, but what's the equation for the, okay, so we know that our surface area is going to be this side squared, okay, plus what else? See, what about this top part? Because it's closed, you know, it does have a top. What would this one be? That one would be s squared too. So we know we have 2s squared, alright, and this side, well, we need a variable for that. What could that variable be? Height. Okay, and we already have it as height, don't we? So we have to do h because we already made the volume equation h, and we would be bad to use different letters. So let's talk about, let me do a checkerboard pattern. Let's talk about that face. What would the equation be of that face right here? That would be I heard SH, that's correct. Alright, this side right here times this height would be the area of that face.
Are there 4 H's?
There are 4 H's, yes. But I don't need to write them because I know they're all H. So yeah, this face right here, let me just darken it, see if that helps. Yeah, there we go. Alright, I don't know if that helped, but this is side times H, right? And how many are there? There are 4, so plus side times H, plus side times H, plus side times H.
Doesn't that give everything?
That does give everything. We found the surface area formula. Huzzah! And essentially now we're done. That's the surface area formula. So this goes right here, 2 side squared plus 4sh, and there's our surface area formula. Now, with our secondary equation, we always use the extra info. Yes?
Can you explain this table and how you get SH?
Okay. Yes, absolutely. Because we have the power of technology and I can overlap different colors. I like pretty colors. Alright, so what we have here is we've already gotten that and that. Those are squares. That's the 2 side square. Okay? Now this face that we've started discussing, we could pick any one. Actually, I could pick this one. Alright? Let's say I was looking at this face right here. Okay, that's a rectangle, yeah? Alright, and do we agree that each rectangle, all 4 of them have the same formula? They're basically the same. And this has a length of S and a width or height of H. So the area of this one rectangle would be SH. But we see that we have 4 of them. 1, 2, 3, 4. 4 panels. Got it? Check. That's why we have 4 SHs. You're welcome. All right. All right. So just all right. So right here now. So we go to our secondary equation and we need help because we need the extra info to help us. The extra info is given in the problem. We have to utilize it. And from there on out, it's simple mathematics. Not simple, complex, but it's the less confusing part. So what do I plug the extra info in for right here? SA, the surface area is 200. You don't have to put feet squared, because we know our units are correct. Alright, so right here, I know that I had a problem. 1, 2, 3 variables. I'm going to use this to get rid of my problem. What should I solve for? Should I solve for S or should I solve for H? Well, considering there are 2 S's, that might be difficult. I don't want to solve for S. I want to. Oh, it is for SH. I'm sorry. I want to solve for H. So everybody go ahead and solve for H. I'll solve with you. We're going to minus 2s squared from both sides. And divide both sides by 4s.
Hey, Coach.
Yes?
Can you explain, like, why it's surface area and not volume?
Volume is what we're maximizing. We're not given any information about volume. So we're given information about surface area, 200 feet squared of material. That's what you're building the outside with by definition. Feet squared is area.
Okay.
So anytime you're given, like, if you let's say you're given extra information like meter squared, you automatically know that your secondary equation is going to have something to do with area. But if you're given information like centimeters cubed, you know your secondary equation is going to be volume, because cubed is always volume.
Okay, because like we're maximizing for volume, so I was wondering why wouldn't it tell you like volume?
That is our primary equation, but that's not what we're going to use. Well, this is what we're going to use to take the derivative. But look, 1, 2, 3 3 variables. We can't maximize volume unless we use something to get rid of one of these variables.
Okay.
Alright, so we're using the secondary equation to get rid of one of the variables. We've already solved for H. We've got 200 minus 2s squared divided by 4s. We can write it nicely as, yes, split it up into 2 fractions. 50 over s. You don't have to. Minus s over 2. Very good. But you can leave it at that if you want to. In fact, let's see what happens when we leave it at that. We can see what happens. It looks like a 5. That's a s. Alright. Actually, I'm going to use this one because I don't know. We'll see what happens. Now, so what did I do this for? I did this so I could get rid of H, and I'm going to substitute this value right here that I have starred in for H, right there. So I'm going to take volume. Volume equals s squared times H, and now it's going to become volume equals s squared times parentheses. I'm going to use that big fraction. 200 minus 2s squared all over 4s. You can use that if you want to. It might be a little easier actually. Now I've got 2 variables. Can I take my derivative? Absolutely, but it would be ugly. So let's simplify it. Alright, by you can distribute, or you could just leave it out factored, one or the other. If I distribute, it'll be 200 s squared minus 2s to the 4th power over 4s. Yes?
You could either leave in the simplified version or the original, right?
Yeah, it doesn't matter. Hold on, let me see if I can zoom in. Chase, could you pull the projector down so I can see my zoom tools? Yes, Asher?
So you, why don't you plug it into the volume and not the surface area? I was trying.
Remember what we're trying to maximize, okay? We're trying to maximize volume, okay? If I, so I need the volume formula. That's what I'm going to take the derivative of. If I'm maximizing volume, I'm taking the derivative of the volume formula. Excuse me. But there's 1, 2, 3 variables. I can't. So I need the surface area formula. I'm just using the surface area formula to get the volume formula to look nicer. Okay? So, let me go ahead and, I don't see my zoom tools up here. I guess I don't know where they are. Let's see. Sorry, guys. All right, so we're almost done. This is still not ready to take the derivative of. All right, so what am I going to do? I'm going to simplify it. This simplifies to v equals 50s. Split it up into two fractions. All right, 50s minus 1/2 times how many s's? 3. Because that would split up into 200s squared over 4s minus 2s to the 4th power over 4s. All right. Now let's go ahead and, excuse me, let me get rid of that. Now, is this ready to take the derivative of? Yes, absolutely. So let's take the derivative. We are taking the derivative with respect to s. All right, we can say the derivative of v is v prime is equal to 50 minus 3/2 s squared. Just the power rule. Just the power rule. Any questions? Any? Okay. Now, so what does the optimization process say we need to do with the derivative to find the maximum or minimum? Set it equal to 0, so it equals 0. 50 minus 3 over 2 s squared. And go ahead and solve. Fast, fast, fast. Multiply by the reciprocal right here. Okay. So what are my two answers? Square root of 100 over 3. And I can simplify that just a tad. It becomes plus or minus 10 over the square root of 3. Now, I know what you're thinking. Do I have to rationalize the denominator? What's the answer to that? No, this is calculus. We don't deal in that extra nonsense. Okay? So, plus or minus 10 over the square root of 3. Those are your two answers. Now, which one do you think is plausible, though? I mean, you have a side. It's a measurement. Can you have a negative measurement? No. So automatically you know that your side is equal to the positive 10 over the square root of 3. And I'm not going to make you do this. Excuse me. It's all off the page. Yes, sir.
Going back a couple steps, so
Yeah.
where it's in brackets. The last part of it, where it's raised to the 3rd power.
Yeah.
Why isn't it raised to the 4th power?
Right here, when I split it up into two fractions, I had s over 4, or s to the 4th over s.
Oh.
And that canceled.
Shouldn't we just look at it as squared?
Where? This right here?
Because our
No, look. S squared times H. H mutated.
Oh, yeah.
H mutated in this monstrosity. Okay, so it changed the S's. There was this different... It had 200 minus 2s squared. And so we multiplied and then broke it up into two fractions. So your S's changed. Alright.
You're not gonna ask us to, you know how you can't have the square root of the 3 in the bottom?
No, do not rationalize the denominator. Alright, you are DUN.
So how do you know if it's the answer is actually positive or negative?
Sorry. DUN. Say that again.
How do you, like, so how do you conclude that it's positive?
Guys. Yes.
How did you come to the conclusion that it's positive rather than negative?
Because when you measure something, it can't be negative.
Oh, okay.
Alright? Thank you. Alright, any questions? Any questions?
That's your answer?
I'm not quite done. I need to find H. So, here's what I got. So, I have got like several different equations. I could use this equation to find H. I could use this equation to find H. I could even go back to the top and use this equation to find H. Or actually all these. I could use any of these equations to find H. So it's up to you which one you want to use to find, which one you want to find H with. I think this one's the best one. So I would plug 10 over 3. Yeah, so it's 50 divided by 10 over the square root of 3 minus 10 over the square root of 3 divided by 2, and that would equal H. Okay? So 50 divided by, and you just plug that in your calculator. Oh, sorry, y'all can't see that. Yeah, I would plug it into this one. That would be the easiest. I don't know. Or
What's
that
our
one.
only options of which formulas to use? Like, can we not use like the primary and secondary equation when we're going to the end and resolving?
Well, what you're trying to do, what do you mean, like options as to what?
Like plugging it into 200 equals really S, which would be 10 over whatever squared times 8. Did you solve for H there?
Yeah, you can use your options are whatever equation has a S and an H. So there's the thing about this one right here, Andrea. Guys, pay attention. Andrea had a good question. All right, what are my options for plugging in my answer? It's 10 over square root of 3. If you look at this one, this has 3 variables. So what am I going to end up when I plug it in? I'm going to end up with 2 variables, and I can't solve.
Well, can't you replace the V with the 200?
Well, the 200 was feet squared, not volume. Not volume. But if it was 200 feet cubed, you could replace it. Y'all understand that anything with a squared I cannot use for volume. It's area. Anything with a cubed I can use for volume. It's not area. All right. So what we're going to have to do now is we're going to have to go ahead and start number 3. Okay. Did y'all get a value for H? What do we get? Square root of 3 over 3? 10 square root of 3.
I got 5 square root of 3.
All right, so let's see. 50 divided by 10 square root of 3, flip, multiply by the reciprocal, you get 5 square root of 3. Minus, flip, multiply by the reciprocal, you get 10 over 2 square root of 3. Wait a second. Yeah, 10 over 2 square roots of 3 equals H. And so you have minus 5 over square root of 3, H. 5 square root of 3 minus 5 square root of, and you could really just plug all that in your calculator. You don't have to do it this way. So you just figure out how to put it in the calculator. And then you would have to get common denominators. So that would make it, hold on, square root of 3, square root of 3 squared. 5 times 3 over the square root of 3 minus 5 over square root of 3 equals h. So 15 minus 5 would be 10 over the square root of 3. Wow, it would be the same thing.
No, it should be 10 square root of 3 over 3.
10 square roots of 3 over 3? Well, when you get common denominators right here,
Yeah, calculate.
the calculator gave that to you?
Yes.
I don't want to challenge the calculator.
I got 10 over the square root of
Well, 10 square roots of 3 over 3? Is that what you're saying?
Yeah.
That's equivalent to this. They're both the same. Because when you rationalize the denominator, which we don't do, okay, you would end up with 10 square roots of 3 over 3. So yeah, cool beans. They're actually the same. All right. Good questions. But we got to move on to number 3. So I'm going to set up number 3 for you, and y'all need to work on numbers 2 and 3 tonight. I'll post a video. I'll post this video, and I'll post a video about number 3 actually after third period, because third period is doing number 3 today. Okay. So here we go. Moving on. All right. So I am going to start an example problem, because I want an example problem and the actual problem for each one of these. So let's take a look at number 3.
Number 3 or example 3?
Example 3. All right, so we have a right circular cylinder with a top. Okay. All right means is that there's a right angle right here, so it goes straight up. Oh my goodness. Okay. So I'm going to try to get this done in 5 minutes or less. Okay, we know a couple things already that we know this has to have a radius, so we already know we're going to label that R. Alright, we already know we're going to label this H, obviously, because it's height, and so we can even do that without knowing anything about what we need to do. Alright, we're just creating our model. Alright, and it has a top, so you know it has a top and a bottom right here.
Wait, Coach, what does that W and H stand for?
Width. Alright, so has a surface area of 9 pi feet squared. So you already know your secondary equation is what? Surface area. Okay, so and actually this is an example, so I'm going to change it to 16 pi feet squared. Okay, 16 pi, and this is the exact example I'll use on the video that I post from next period. Alright, so and then what it's asking, what height and base and base radius will maximize the volume. So we want to maximize the volume. We want to find the height and base radius, which is the same as the top radius. It doesn't matter. Okay. So with all this information, looking at our model, we already have the correct model with all the variables that we need. We've got a base radius, we've got a height, so we're good to go on our model. The model is happening. It's awesome. Now let's start by writing our primary equation. What is our primary equation? The formula for the volume. You always know your primary equation is what you're maximizing or minimizing. Okay, so volume, we already talked about this. This is a circular prism. All prisms' volumes are base times height. Big base though. Big base. So the big base is referring to the area of the base. What is the area of the base? What's the area of a circle? No, pi r squared. Remember, area. Y'all I forget sometimes too. But if you remember that area is always a unit squared, you remember area is pi r squared, and circumference is 2 pi r.
But wouldn't it be like 2 if you have 2 top and bottom?
You're absolutely right. But when you're talking about the volume formula, we're just talking about one of the bases. Okay? But when we do surface area, Leslie, you'll be absolutely right. Oh, where's my pencil going? Come on, pencil. All right. Got to reload. Oh. Misfire. All right. So our base is pi r squared times h, right there. Now, the tricky part here is finding the surface area. Okay? So the surface area is going to be equal to, let's break it down into its parts, okay? What is our surface area? So what's the area of this right here? That would be pi r squared. That's the area of a circle. Do I have to include this area? Yes, because it's with a top. So plus pi r squared. Now how would I find the area of this all the way around?
The circumference
Yes.
times the height.
Yes, it would be the circumference times the height. Good job. Have you ever done one of those things that you pop open and make biscuits with, and you roll the side out? So that's what we're trying to do. We're trying to roll this side out. Okay. All right. So if we roll it out this way, just like Andrea said, the length on the bottom is the circumference because it's the distance around. So the length is not L, it's 2 pi r. Okay, you just have to imagine rolling that cylinder out, and the height is still h.
Did you add that on or multiply the height?
Well, how do I find the area of a rectangle? Length times height, or whatever, base times, yeah. This length times width. And so the area of this rollout is h 2 pi r, or 2 pi r h. Now how many of these do I have? Just one. So plus, let's say 2 pi r h. So yeah, awesome. There's our surface area formula.
And that's for the whole.
So our secondary equation is surface area equals 2 pi r squared, because there's two of them, okay, plus 2 pi r h. Now, what am I going to use for my parameter in my surface area? 16, because that's what was given, right? 16 pi. 16 pi equals 2 pi r squared plus 2 pi r h. Misfire. Dang it. Uh-oh. I got to reload again. There we go. Alright. So, let's take a look. What was the problem with our volume formula? 3 variables. Could I maybe solve for something here? Absolutely. I would solve for the h and then replace this h in my volume formula. And that's all the time we have for example today. And you know, I've still got your homework from last night, but I guess you're done with that. You're moving on to numbers 2 and 3. I'll check that off and get it back to you as soon as possible. I'm just going to look through them. It won't take that long. All right, that's it for this.
After you plug for H, would you plug it back to the original?
Yes, I would.